working with graphs. And we've been dealing with graphs and working with graphs for a few days now. When dealing with graphs, we have a general equation y equals our vertical phase shift plus or minus our amplitude, sine or cosine, b, theta minus a horizontal phase shift. Where a, once again, our amplitude is absolute value of a. When we talk about the period, this is calculated by 360 divided by b. Our vertical phase shift gives us our prime axis. Our vertical phase shift gives our prime axis. Our horizontal phase shift gives us our theta start value. When we're talking about sine, we are starting on the prime axis. When we talk about cosine, we're going to start at a peak or a valley. Okay, when we're talking about a peak, this will be a negative or a positive with the amplitude. This will be a negative with the amplitude when we're talking about a valley. When we have a positive amplitude for the sine, we go up first, we climb the hill first on a roller coaster ride, and then slide down and back up again. When we talk about a negative amplitude with the sine, we go down first, then up and around. Our games of halves, we talked about our games of halves. That will give us our critical points within our graphs. Last thing I ask you to find is the y-intercept. And take your graph to this y-intercept. This is where theta is equal to 0. So you sub 0 in for theta, and you just click it through the calculator and come up with your y value. And this will give you your y-intercept. So when dealing with graphs of sines and cosines, it is pretty much the same process each and every time as you go through this. You find all the pertinent information. When I talk about pertinent information, we have these 4 tidbits, and we have the y-intercept here. And then we start going through our process in regards to how to deal with the graph at each level. Now, some of your graphs that you have here, I don't know why they get a little ludicrous with their numbers. I don't know why that they do what they do. My suggestion when they get ludicrous, like in number 6, you have 1,000 plus 3,000. You just count out by thousands. 1,000, 2,000, 3,000 on your y-axis. You keep it simple. I'm not going to give you horizontal phase shifts like you have in problem number 17 or problem number 4. I will keep the vertical phase or the horizontal phase shifts at 30s and 60s and 90s. I'll keep them at that level. I'm not going to put you in a position where it's going to really give you some awkward numbers, because what I want you to be able to do is have ease in regards to getting your graph down. Okay, so getting your spacing down your graph, I want a little bit more ease for you to be able to do that. Questions, problems that you would like me to go through? Any of the problems you'd like me to go? Once again, you need to keep up with the material, because it will hit you like with a baseball bat here real quick. As we start going through these things, we keep things moving, but I will pause and we'll go through things as you need me to go through them. Is there any issues that we're having with graphs? I'm hoping that the problems that we do in class, okay, we get through 3 problems or 4 problems in class, that gives us 3 or 4 problems of practice. Even if you can pick up 2 or 3 problems from your homework, that gives you additional problems from your homework. If you get them all done, that will give you additional practice. Once again, practice gives you confidence. Confidence will give you success in doing the problems. If you don't get practice, you don't get confidence. If you don't get confidence, you're not going to have success doing the problems. So those 3 things are connected together, and it has to go in that order. Okay? It just doesn't jump to confidence right away. I'm going to practice, and then that's going to give me success. You have to get practice in first, That will give you confidence, and then you're going to get success. Things you need me to go through. All right. Sorry if you're bummed that we're here today and that we weren't even at least on a 2-hour delay. Sorry about that. But as we talked about in statistics, we're talking about probabilities of people predicting out in probability. Okay, your probability your snow day calculator had a probability of 42% chance of probability or having a snow day today. 42% chance. Well, that means there's a 58% chance of having school today, which is more likely than complement principle. And see, to me, I looked at yesterday afternoon when it turned sunny all afternoon yesterday afternoon, and they were calling for cloudiness all afternoon. The chances of us having a day off today were going to be slim then, because they were starting to get it wrong yesterday afternoon. Not to say I didn't have a little coating on my truck this morning I had to scrape off, but roads were not bad. Okay, today we're going to put the process into reverse. Okay, up till now, we've been given an equation. And from that equation, we found that the amplitude, the period, well, sorry, not bad. Is this anybody else? Okay, we've been given an equation. With that equation, we found the amplitude, we found the period, we found the vertical horizontal phase shift, y-intercept, and then we graphed it. And that's what we did up till now. What we're going to do today is we're going to take the graph of a sine or a cosine. We're going to take the graph of the sine and cosine and put the process into reverse. From the graph, we're going to find the amplitude, the period, the vertical horizontal phase shift, and then determine what the equation is. So we're just going to put the process in reverse. Once again, we have our general equation that we will continue to work with. Y is equal to vertical phase shift plus or minus the amplitude sine cosine b theta minus horizontal phase shift. Okay, we will still continue to work with that base equation. But once again, we're going to give you the graph now. And with that graph, we're going to determine from the graph the amplitude, the period, the vertical phase shift, and the horizontal phase shift. And then come up with the equation. Well, the first thing in determining this, and there's some numbers in here. It's like -1, 1, 2, 3, 4, and 5, and 6. 2. We're going to start with the same process as we started with respect to graphing. What we graph first is we graph the vertical phase shift, or the prime axis, because with that prime axis, we're able to oscillate, we're able to find other information. We're able to get our graph down. So what we're going to want to do first is draw in our prime axis. Well, if I take a look at my graph, I peak out at a value of 5. Here's my top value, 5. My bottom value here is -1. Where would we draw in a prime axis? At what y value would we draw in a prime axis? Isaac?
2.
At a value 2. Now, how'd you come up with, why'd you say 2?
Because it's halfway between 5.
Yeah, you have to find the halfway point. The halfway point. Because we have to be able to oscillate up from this and down from this, and we have to be equal up and equal down. So we had to find the halfway point between 5 and -1, which gives us our vertical phase shift. The next easiest thing to find would be what? Amplitude. What's our amplitude going to be? 3. Because by definition, our amplitude is defined to us as a distance from our neutral axis to our peak or to our valley. So how much do we go up? How much do we go down? So we go from 2 to 5 or 2 to -1. So we have an amplitude of 3. Next thing we want to deal with is the period. Now the easiest way to find the period is to go from peak to peak or valley to valley. Find degree measures that are from peak to peak or valley to valley. And that will give us the period. And it does not matter which one you deal with. You take a look at this valley and this valley, or this peak and this peak. What is the number of degrees that we have? 180 degrees. 180 degrees. I go from -60 to 120, or 30 to this value here looks like 210. So we go from peak to peak or valley to valley. But what we need in our equation is we need to know a b value. Well, the period was calculated by 360 divided by b. If I multiply both sides by b, I got peanut butter is equal to 360. So if I divide by the period, my b value is 360 divided by the period. Period's 180 degrees, so the b value would be what, Ella? 2. So we get a b value of 2. Taking your 360 divided by the period. Now, the horizontal phase shift. The horizontal phase shift. Now, when dealing with these problems, and you're determining an equation, there will be an infinite number of solutions. An infinite number of solutions, depending on what you choose your horizontal phase shift to be. The first 3 tidbits of information we threw up there, the amplitude of 3, the vertical phase shift of 2, and the b, or vertical phase shift 2, and the b value 2, those 3 will be the same in all these equations. The fourth element, the y-intercept, will be the different, or not the y-intercept, the horizontal phase shift will be the different one. My suggestion, I'm a KISS person. I like to keep it simple, stupid. So I try to do the same thing over and over again. Unless something falls right into my face, I try to keep it simple. When I try to keep it simple, I find the nearest peak that is marked to the y-axis. So I go to this value right here and find my degree measure. And I use that as my horizontal phase shift. The reason why I do that is if we use a peak, what goes into our equation? Cosine. And to be even better than that, positive or negative? Positive cosine. A positive cosine will be in your equation. That's why I go to that. It's going to be positive cosine. I don't have to worry about negatives. I don't have to worry about anything else. It is a positive cosine. So my equation, I can write my equation, y is equal to my vertical phase shift, which is 2, plus my amplitude, which is 3, cosine my b value, which is 2, and theta minus our horizontal phase shift. And there would be our equation. Well, what if you want to come out here? That's fine. This is correct. If you want to write that equation, that is correct. Suppose you want to come back to here and use negative 60. Now we're at a valley value. When we're at a valley, we have a cosine still, but it's now negative. So we have theta minus a negative 60 or theta plus 60. That's the correct answer. But I have to have a negative with my cosine now. If I want to use 110, that is fine. This would just change this to a minus 1 or 120. That is fine. That's the correct answer. Suppose you want to do some work here. Let's see. This is 30 here. So it looks like this would be 15. And you want to use a sine curve. That's fine. Y equals 2 plus 3 sine 2 theta plus 15. That would work. If I wanted to do some work and find this value over here, it'd be 75. But now it's going down first. So I'd have y equals 2 minus 3 sine 2 theta minus 75. That would work. Once again, you have an infinite number of solutions. If you want to come over here and use this value here, this looks like 165. So I'd have theta minus 165. That would work. Infinite number of solutions. Once again, if you want to keep it simple, and this is what I'm going to do each and every time, go to a peak and do a positive cosine. Sometimes something will fall out though, and it will look like, you know what? This looks like a sine curve. I can use this horizontal phase shift and do a positive sine curve. That's fine. Do it. Use it. It's okay. Let's see here. Looks like we have 1, negative 2, negative 3. We bottom out at. Drawing your prime axis. Where would your prime axis go? Drawing your prime axis. Find your vertical phase shift. And find your amplitude. Find the period, peak to peak or valley to valley. Find your B value. Then choose a horizontal phase shift you want to use. You might have to do a little bit of mathematics and find a peak. That's fine. Use your game to halves. If you want to use a valley, go ahead and use a valley. If you want to do even more work, you can use a sine curve. Check your answer with somebody around. Do that. then write your equation. If we take a look at the amplitude period, the B value, and vertical phase shift, Sarah, what do you have for these values?
Amplitude is 2, period is 90, vertical phase shift is -1.
What do you get for the B value?
4.
Okay. So those values should be the same for every one of your equations. Okay. What changes now is what you use for your horizontal phase shift. What changes is what you use here. Okay, somebody may use the same, somebody may be different. That is fine. Vanessa, what do you use?
-45.
-45. Okay, what was your equation?
Y equals -1 plus 2 cosine of 4 theta minus 45.
You use -45?
No, I use
Okay, positive 45. So we use positive 45. So she did our games of halves to get this value here at 45. That is fine. Okay. You could also use -45, and then that would turn into a plus 45 here. Anybody use anything different? Anybody use a different horizontal phase shift? You would use 0. You have this value right here. It just goes to a valley. And what it does is it simplifies your equation. Y equals -1 plus 2 cosine, or minus 2. Or theta. And just use this value right here to start the valley. Eliminate your horizontal phase shift. Once again, if you use a sine curve, you would have to do another games of halves. You would have a 22.5, 22.5 here. This negative is positive. We could use a sine curve if we wanted to. Look at the last one here. We have -2, -1, 1, and 2. Find your pertinent information. Determine an equation. And once again, check your answer with somebody around you. Find the amplitude, period, vertical, horizontal phase shift, B value. Okay, if we take a look at the numbers here, amplitude period, p value, vertical phase shift, Lucas, what do you have?
Amplitude of 2, 1080.
1080 for the period? How'd you get 1080?
It should be 720, right?
720. How'd you get 720? Well, peak to peak. So we go from negative 180 to 540 degrees. Okay, so we have 180 degrees here. We have 540 degrees here. That would be 720. Or if we would go 180 to 900, 180 to 900, take 900, subtract off 180, you get 720. So either way you can do it. You just have to figure out a way that works best for you. Okay, peak to peak, valley to valley, you're subtracting your values here, which means your B value is what? 1/2. Taking 360 divided by 720. 360 divided by 720 will give us a 1/2. And then vertical phase shift, what do you get? 0. Okay. Where prime axis, I go from 2 at the top, I go negative 2 to the bottom, so I have no vertical phase shift here. Now the horizontal phase shift, that's up to you. What you want to choose for your horizontal phase shift. Paul, what'd you use for your horizontal phase shift? 180 degrees right here. So use 180 degrees. What's your equation?
Y equals 2 cosine 1/2 to theta minus 1.
Okay, he has 2. We have no vertical phase shift there. We have no vertical phase shift, so we have no values out front. Okay, we have 2, which is our amplitude, cosine 1/2, theta minus 180. Okay, one little issue with that. What's the issue? Should be what? It should be. It could be cosine. We're in a valley here, but there's another issue here.
Negative.
Should be a negative. Should be a negative because we're at a valley. Okay, we're at a valley here. Now, if you would have went to this negative 180, if you would have used negative 180, then that would be a positive cosine. But you would have a plus inside there. So we would have y equals 2 cosine 1/2 theta plus 180 minus negative 180 or plus 180. Did anybody use sine? What's your equation?
Y equals -2 sine 1/2 theta.
That's correct. Went no horizontal phase shift. Went to this one here. I'm here on my prime axis, but we went down first before we went up. So we have to make sure we get our negative in there. We get our negative with the 2 in there because we go down first and then back up. If you use 360, that would be a positive sine curve. Okay. Once again, infinite number of solutions. Homework, page 54, you have problems 9 to 16. 54, problems 9 to 16. You are given the graphs there. What you should write each and every time as you go through the problems. You should get this information down first, and then go to your equations that you need to write then at that point. Page 54, problems 9 to 16. Once again, graphs are given. They even give you a prime axis in there. They try to make it simple for you. All right, you have about a little 8 minutes, 9 minutes. Should be able to get a few of these done here in class. Time is yours.